Welcome to Study Loop.
Hello everyone, today we're doing chapter 29, problem 4, and this problem asks us what alpha halo carbonyl compound is required to synthesize each of these following amino acids. So when we want to prepare amino acids using SN2 reaction of an alpha halo acid, what we need to do is that we have some sort of amino acid precursor, you could say. So I can draw that amino acid precursor starting from the CN, but instead of this N in the beginning, we're gonna add a halo group, so being one of those halogens that we have. So we can have bromine, chlorine, any halogen, and then off the alpha carbon, we have our R group. So now if I were to react this with excess ammonia, NH3, then we could see that this would act as a nucleophile with lone pair electrons and go through an SN2 mechanism to go through a backside 180 degrees attack on the alpha carbon that's bound to this alpha halide, making a bond. When you make a bond, you break a bond, so the leaving group is going to be the best leaving group, which is typically going to be the halogens, this one being bromine, so bromine's going to pop off, and we are going to now get our amino acid being formed now through an SN2 mechanism using excess ammonia. So using this using this kind of reaction scheme, we could see that all we need to do is, instead of having the amine here for the NCC backbone, we just need to replace that with a halide bromine, for example. And this will be the alpha halo compound required to synthesize any of the amino acids. And R group we would define with R group in the question stem. So A, it asks for glycine. So glycine, we know that has an R group that is hydrogen. So now let's draw the R group being hydrogen. This one will be bromine. And now if I add excess ammonia, we will get an SN2 attack, replacing the bromine and forming now our amino acid glycine. In B, it asks for isoleucine, so we can draw isoleucine. Isoleucine kind of looks like an eye, so we can draw those 1, 2, 3 carbons, and a fourth one will come off the first carbon right there. And now we can add our halide that's going to be kicked off by reaction with excess ammonia. And then we will get now our amino acid being formed. And last but not least, in B, we have phenylalanine. So phenylalanine, these amino acids are something that you guys have to kind of remember, use some tricks to help you memorize. Phenylalanine essentially is a benzene ring with one carbon linker. Reaction with excess ammonia. Gives us now our amino acid phenylalanine.